The learning objective of this section is to find the elasticity of a demand function. And we'll do that by using this formula right here and solve application problems involving elasticity of demand. So a demand function will be given to us. It's going to be d of x. It relates the quantity p of units purchased to the price x in dollars per unit, and it is usually a decreasing function. Okay, and I'll explain why. The demand function is usually a decreasing function. If you watch those application problem videos from 3.6, you remember as price goes up, the demand usually comes down. If things get too expensive, people don't want to buy it anymore. Unlike it's like Apple or, name brand. Like the more expensive it is, people want to buy it more. But usually, in general, demand function is a decreasing function. As price of something goes up, the quantity of units purchased is going to go down. Retailers and manufacturers all often need to know how a small increase in price will affect demand and total revenue. So like questions like, can I make my product a little bit more expensive? And will I still be able to increase the profit? Or if I make it any more expensive than what it is right now, will the profit actually go down? Okay, so to measure the sensitivity of demand to a small increase in price, economists calculate the elasticity of demand. So here's a word, elasticity of demand. And the formula goes like this. We're going to use calculus to find this. So the elasticity of demand function, or V of x, is not just derivative of dx, okay? What we have to do is multiply, we're going to find it, but then it's going to be on opposite side. So negative x, whoopsies, it's going to be negative x times, okay? You have to find the derivative of the demand function, and you have to divide that by the demand function. Okay, so I'll show you how to do this. Okay, maybe I'll just erase this. All right, so after finding this elasticity of demand function, you're going to plug in the number they will give you, okay? They will ask you, hey, what if the price is $5 or $2? What will happen to the demand if we increase the price a little bit? When the elasticity at x is smaller than 1, then what we say is, say it is inelastic. Inelastic. So once you find the demand, the elasticity function, that E of x, you're going to plug in the price they give you, $2, $3, $5. Once you plug that number into the E function, if that value comes out to be smaller than 1, we say the demand is inelastic, and what that means is a small rise in price will result in an increase in total revenue. That means they can bring up the price a little bit and they'll be able to make more money out of it, okay? But what if it comes out to be greater than 1? When you plug in that price, x, into the elasticity function, and if it comes out to be greater than 1, then we say the demand is elastic. What that means is a small rise in price will result in a decrease in total revenue. So at that point, they really shouldn't raise up the price, right? Rise up the price. So what if it's equal to 1? If it's equal to 1, then we say that the revenue is maximized at that point, okay? And we say this is a unit elasticity. Unit elasticity. So that's it for really, the formula and how to determine these, but we should look at some examples together, okay? So here's the first example. Theorem 11 just kind of organized what we talked about. Here we go, example number 1. The demand for video game rentals at Clicks Video Games is given by Q equals D of x equals 120 minus 20x, where Q is the number of video games rented per day at X dollars per rental. They want us to find the elasticity of demand as a function of X. So we need to have the formula. So let me go and copy that formula. Here it is. And I'll put it right here, okay? So to find the elasticity function, I'm going to need to find the derivative of the demand function. So we have the D of x here. D of x is 120 minus 20x. But underneath it, let me go ahead and write down d prime of x. I need the derivative. That will just be negative 20, right? Negative 20. So I have all the pieces I need to find the elasticity function. E of x equals negative, I need a fraction, x, put the x, and I'm going to multiply this by d prime of x, which is negative 20. And I'm dividing this by d of x, which is 120 minus 20x. Let me simplify this, okay? I noticed that there is negative here and there's negative 20 here. If I multiply negative times negative, that will give me 20. So I'll write down this is 20x on top of the fraction and 120 minus 20x in the denominator, okay? And that is the elasticity function, okay? I guess we can do more. We can simplify everything by 20. I noticed that. So because all of these numbers are divisible by 20, 120, and 20. How about we just simplify that? I can say this is equal to x divided by 6 minus x. So that is the elasticity function. Circle it. Now let's use this. Okay, they're going to give us some price. Find the elasticity at x equals $2 and x equals $5. Let me do $2 first. Okay, I think it's in dollars, right? Yeah. So what is E of 2? If I plug in 2 into that elasticity function, I will get 2 divided by 6 minus 2, which is 2 over 4. And I can just say that is half. But look, half is smaller than 1. And whenever that elasticity function gives you an output that is smaller than 1, what we have to say is this price, it is inelastic. Okay? Which means a small rise in price will result in an increase in total revenue. Okay, so at that point, they can increase the price a little bit. What if it is $5? Okay, I have to plug in 5. That will give us 5 over 6 minus 5, which is going to be 5, right? 5 divided by 1. And this is definitely greater than 1, which means this price, this is going to be elastic when the demand is going to be elastic when the price is $5. And what does that mean? That means if they make this product or video game any more expensive at this point, the revenue will actually go down. So they shouldn't make this video game more than $5. But when is the profit maximized or the revenue maximized? Find the value of x for which E of x is equal to 1. So they're asking us to find the unit elasticity. So the significance of this price, okay, this is going to be the unit elasticity. This is going to, the demand will be maximized here. Okay, and we say, look, the total revenue is maximized at that price. Total revenue is maximized when x is, all right, let's find it. Okay, let's find it. Now, when they ask us to find E of x equals 1, okay, this does not mean do not find E of 1. Okay, we're not plugging in $1 into the function. We have to set the elasticity function, this function, equal to 1. Okay, so take a look. I will have to set up 1 equals x divided by 6 minus x. Okay, I need to set that function equal to 1. I'm going to multiply both sides by 6 minus x. If I do that, I will get 1 times 6 minus x equals x. Okay, I multiply both sides by the bottom of this fraction. I can just say 6 minus x is equal to x then. Adding x to both sides will give me 6 equals 2x. Dividing both sides by 2, I will get x is equal to $3. So their revenue will be maximized when this video game is $3. Okay, so that's how you can do this problem. Now this section is extremely short. So I think I'm just going to be able to finish this in 2 videos. So I'll go ahead and stop this one now. And then I'll come back and record another one for example 2 and 3.